In the Onshape Assemblies course, you learned how to use mates to define part motion in an assembly. Through the use of mate connectors, multiple degrees of freedom are defined with a single mate. Mates do not simply define the position of components, but also help visualize exactly how components move relative to one another in an assembly. The mates introduced in prior courses define motion between two parts. In cases where more advanced mechanical relationships are required, such as gears, rack and pinions, screws, or linear motion, Onshape provides mate relations that define motion between mates to ensure assembly motion is validated during the design process. The gear relation relates two mates with a revolute degree of freedom. This mate relation creates a constant ratio of angular rotation between the 2 degrees of freedom, allowing components to rotate with one another when one of the components is moved. The rack and pinion relation relates a rotational degree of freedom with a linear degree of freedom. If a component is rotated, another component moves a prescribed linear distance per rotation, or vice versa. The screw relation functions just like a typical screw fastener by constraining the rotational degree of freedom in a cylindrical mate to the translational degree of freedom in the same cylindrical mate. As the component rotates, it also translates along the axis of the cylindrical mate. The linear relation relates the linear motion between two mates to translate at a constant ratio. As the first mate moves linearly in one direction, the other mate is also moved linearly in one direction. These mate relations provide an easy way to define the common mechanical relationships designers typically employ within their designs. The following videos in this lesson dive into each of these in more detail and show examples of how and where these relations may be used.